Hey, I am Karan Upadhyaya from the Department of Electronics and Electrical Engineering and my roll number is 200108064. This is video assignment on lecture 9, which is expected values from the course EE230 Probability and Random Process. Problem is the friendship paradox. The friendship paradox is often expressed as saying that on average your friends have more friends than you do. How will you show this mathematically and what can you tell from the answer? Now let us approach to the solution. Let there be n people numbered from 1 to n and let fi denote the number of friends of ith person and let f be summation of fi from I equal to 1 to n. For example, in this graph, each circle denotes a member, that means n equal to 4, and each line denotes the friendship, that means 1 and 2 are friends, 2 and 3 are friends, and so on. So f of 1 should be number of friends of 1, that is 3, 2, 3 and 4, and so on. So f will be summation of these f's from 1 to 4, which is 8. Now x be a randomly chosen individual. So for any member it is equally likely to be chosen. That means probability that a chosen person is ith person will be 1 by n. Now expected value of number of friends of x will be summation of fi into p of x equal to I. That means probability that x is ith person and number of friends of ith person. So which is equal to summation of I equal to 1 to n f of I and p of x equal to I is 1 by n. This is constant, we can take it outside, and summation of fi from 1 to n is nothing but f. This is what we wrote. So expected value of fx is f by n. Now let every person writes name of each of his friends in separate sheet. That means if one person has 3 friends, he writes 3 of their names in separate sheets. That means ith person appears on fi sheets of paper and total number of sheets will be sigma of fi from I equal to 1 to n, which is nothing but f. Let us choose one of these sheets randomly. And y be the name of the person whose name is written on the sheet. So probability that y is ith person will be fi, which is number of friends of I, by total number of friends, which is f. Now what is the expected number of friends of y? This is nothing but e of f of y, which is equal to summation from I equal to 1 to n fi into p of y equal to I. That is the probability that y is ith person into the number of friends of I. P of y equal to I is nothing but f of I by f, which we derived earlier, and f of I into f of I will be f square I by f. Now what we do is we divide numerator and denominator by n. So the denominator will be f by n, which is e of f of x, and the numerator is summation of I equal to 1 to n f square I by n, which is e of f square x. So e of f of y will be this ratio, which is e of f square x divided by e of f of x. Now here comes the crucial part. We know that expected value of the square of any random variable is always at least as large as the square of its expectation. That means e of f square x is greater than or equal to e of f of x whole square. So the numerator is greater than or equal to e of f of x whole square. This takes us to the inequality e of f of y greater than or equal to e of f of x. This is the answer to our problem. E of f of y, number of friends a random friend has, is greater than or equal to E of f of x, number of friends that you have. Why is it so? This is because y is a randomly chosen friend. The person who appears the most in the sheets is more likely to be chosen. He appears in the most of the sheets only because he has lots of friends. That means y appears when you choose a friend only because he appears in most of the sheets. So that is it. Thank you.